Hey Defenders, welcome back. In this video, I'm going to introduce you guys to our new series that I'm calling the World's Best SOC Built on Open Source Tools. In this video, we're going to cover what I believe are the key elements that make up a SIEM stack in order for you to be able to have a competent SOC team, as well as the open source tools that we will deploy throughout this video series that meet each of these target goals that we're looking to achieve. So let's go ahead and jump into it. So for the flow of this video, we are first going to discuss what makes up a good SOC. So what kind of key pieces do you need in play? What type of backend storage do we need? What visualization tools are helpful, right? So what tools are required to compose up a full SIEM stack, right? And then what free tools are available? So what tools out in the open source world fit into each of these various categories and overall make up our total SIEM stack? We're then going to get into the architecture overview of how these tools will be integrated with one another, and then we will jump into the deployment strategies. So first things first, let's go ahead and get into log ingestion. So this, of course, is a critical piece into our SIEM solution because we have to be collecting some type of logs, right? Whether that be endpoint logs, network devices, third-party services. Maybe I'm using Office 365's API, or maybe CrowdStrike has some log forwarder that we're taking advantage of. So first things first, we need to start ingesting logs, right? We then need a way for us to normalize our fields. And this will hopefully become a little more obvious later on in the video. But for a quick example, maybe let's say our Apache access logs that we're sending to our SIEM, right? Write their source IP field as source_IP. The metadata within this field details to us what external IP address is connected to our various web apps, where maybe our firewall is logging the source IP address in a source_IPv4_IP field. Well, these are two different fields that contain roughly the same metadata, right? And we want a way for us to be able to rewrite these to a common universal field. And this will allow us to build universal dashboards. This will make our alerting configuration much easier because we're not having to create separate dashboards or separate alerts for, let's say, for example, source_IP or source_IPv4_IP. We're not having to run through the same task because we're able to normalize these two different field names into one. And that'll hopefully become more obvious in our example later on. We then also need a way for us to ensure the caching of logs if storage is busy. So our backend storage throughout this series is going to be Elastic, but let's say, for example, Elasticsearch is down for whatever reason. We need a way for us to, rather than losing visibility into those logs because Elasticsearch is down, we need a way for us to be able to cache those logs for a period of time until Elasticsearch is healthy, and then we can write all of those logs to Elasticsearch without missing any security related events, right? So we need a way for us to ensure that we have a little bit of fault tolerance in there as well, outside of just like a multi-node Elastic cluster, which we'll discuss all that later on. We need a way for us to be able to analyze our logs. We need a way to customize our rules to fit our environment's needs. We need a way for us to set, rule severity. So, hey, if we see X, Y, and Z happen, that results in a high severity alert. We need customization around all the kind of meta details that make up our alerts as a whole. We need a way for us to be able to analyze those and match those up against rule sets. So, for example, if I see PowerShell executed with the execution bypass flag, right? We need an alert that's saying, hey, this is potentially suspicious activity because we see PowerShell was invoked with the execution bypass flag, right? So we need a way for us to analyze the logs that are coming in real time and categorize those out accordingly. We then also need the ability to discard noisy alerts or limit overflow of unnecessary data. So let's say, for example, I'm collecting syslog events from one of my firewalls, and the firewall is configured to be sending a ton of TCP teardowns, right? that may be something that we may not care about TCP teardowns, and we don't want those logs taking up this space on our backend. Maybe the amount of TCP teardown logs that are being sent to our SIEM stack is, let's say, 50 gigs a day. Well, this space is not free, right? So we want to make sure that the logs that we are storing are also logs that could be of importance for us during an analysis, right? And TCP teardowns in our situation may not apply to give us kind of any wealth of information that we would need during an investigation. So we want to go ahead and tune those out. So we also need the ability for us to be able to tune things out of the logs that we are receiving rather than tuning it out at the source, right? So maybe I could configure the firewall to stop sending TCP teardowns as part of syslog events, but there may be some devices where we don't have that control, so we can actually control that at the log ingestion piece of the SIEM, right? And that just gives us more flexibility to log and store what we actually deem as valuable. Now, talking about our backend storage, this is our key piece of our SIEM stack. So not only do we need to be able to store the logs, but we also need a mechanism to where we can search on various fields within our logs within real time, and something that's scalable and fast, right? Otherwise, our solution is really no good. So we need to be able to store logs for periods of time. We need to be able to search on that data very quickly and be able to view that data. And then we also, depending if you're running a multi-tenant stack or not, we need the ability to provide access control. So who has the ability to view, logs from customer A, who has the ability to view logs from customer B, and so on and so forth. So backend storage, really, without that, you don't have your logs. Then we get into our visualization. So we need a way for us to view the logs from a more human-friendly view, and something that's easier on the eyes and will allow us to, quickly pivot on certain alerts. Will make it obvious to whoever's looking at the dashboards. Okay, these are my high severity alerts. Maybe I want to look at all DNS queries made by this endpoint. Right? We need these visualizations to make it easier on our SOC team to be able to work their way through logs that we are ingesting, right? This needs to be fast, and this also needs to support multiple log storages. So something being Elasticsearch/OpenSearch, MySQL. Maybe I have an API that responds in a JSON format, and I want to use that to populate a dashboard. Maybe I want to read from a CSV file and populate a dashboard, right? We need to have a visualization tool that can serve all these different use cases, so that really kind of no matter what we're trying to view, we have the ability to do that. We then get into our intelligence enrichment, right? So we need a way to automate this process, right? We can't ask one of our SOC analysts, hey, for every IP address that we saw this endpoint connect to, I want you to run it through VirusTotal, or I want you to run it through MISP manually, right? That doesn't scale well. We need a way to do this automatically so that we can then build our alerting off of it accordingly, right? Rather than a human having to do that analysis, we actually make the tools themselves enrich our logs with this analysis, and then depending on what we get back, then we alert accordingly, right? So intelligence enrichment is a big piece of this that, in my opinion, if your SIEM solution doesn't have something like this baked in, it is not up to par to where it needs to be, and you're probably missing out on potentially security incidents because you're not getting your logs backed with this threat intel. So it makes it even more harder to identify when maybe an endpoint has connected out to a known command and control server, or has written a file to disk that has a malicious hash value that's well known throughout the industry, right? So we need a way to not only enrich our logs with this type of intelligence, but also to automate it so that we can scale out as our environment grows. We then get into our case management. So even when we get our dashboards set up how we want them to be, it can still be difficult for SOC analysts to work on alerts at the same time. Maybe it can be maybe not obvious to them, okay, all these alerts are populating my dashboards, but which ones are actually but which ones actually require some type of human intervention or human analysis. And we also want to give them the ability to run various actions on a particular endpoint. So, and a case management solution allows us to do this. So, it'll allow us to say, hey, for this security incident, I'm going to go ahead and make that a case where I can now collaborate with other team members on my team to run various tasks, right? Maybe let's say, for example, we get an alert that Mimikatz has been ran on an endpoint, right? We take that into our case management solution, which is also popular, can also be populated with playbooks and various workflows, right? And we want the ability to investigate that a little further, but also have a record of those actions that were taken against this alert as well. So maybe as a SOC analyst, I go in, I list out all of the running processes for this endpoint that triggered this alert, and I say, oh, I see Mimikatz is actually running on the endpoint. Now, okay, let's go ahead and escalate this alert even higher up. And now we need to really take some actions. Maybe I want to quarantine this box or whatever escalation procedures you and your team have determined on. Then that's the actions you will take. But we need a tool that will help us organize these events and then also be able to, and also allow us to take these kind of more responsive actions from the same platform. We then want to automate. And I can't stress that enough. You want to try to automate as much as is humanly possible. I know that's a lot easier said than done, but especially in the security world with how fast things are moving, with how big networks and the number of endpoints that are on networks are becoming, it is just not possible for humans to sift through and analyze through all of these events that will be hitting our platform. So we need a way for us to automate as much as possible when it comes to the, threat intelligence, to the case creation. Maybe if I'm really crazy and I have like a strict process in line, I could automate the quarantining of a device. I don't recommend that unless you are 100% confident that when a quarantine happens, it needed to happen, because you can, of course, affect any business operations that could have negative effects on your business. We also want to, automate failed health checks, and we'll get into a lot of this throughout the series. And we also need something that we can customize and integrate with anything, and is also fast and can scale out as the number of events that we're ingesting also start to increase. We then also need a tool that will allow us to investigate. So it can be very frustrating with SOC analysts if, let's take our Mimikatz example alert. A Mimikatz alert comes in, and then that's all the SOC analyst can do. All the SOC analyst can say is okay, I see this alert. Now, how do I maybe verify that this alert is a true positive? How do I maybe quarantine this device, right? We need to provide our SOC analysts the ability to do that in a simplified manner that is easy for them to understand, is powerful, and is also fast. If a Mimikatz alert comes in and a SOC analyst has to reach out to Dave, they have to reach out to Bob to do something else, and let's say that takes 5 hours rather than just 5 minutes, that the SOC analyst could have determined this true positive and then taken responsive actions. That's just more time that whoever or whatever is on that endpoint that is doing these malicious activities, that just gives it more time to make their way throughout the network. So we need a way for our SOC analysts to be able to investigate alerts very, very quickly. We then will get into our health monitoring, right? So these tools will likely be running on different servers across the board. They will be different processes will make up these tools, right? So we need a way for us to monitor that the servers, the processes, and even up to the web applications, right, that some of these tools are serving for either our customers or for our own internal use are in a healthy state, right? And if they're not, we need the ability to alert in real time when a health check threshold may have failed, so that we can proactively identify a potential stoppage or issue occurring before it actually happens. So now let's discuss what open source tools are available. So we went through what elements that, in my opinion, are required to make up a legitimate SIEM stack that actually allows your SOC analyst to succeed. So now, okay, what free tools are actually out there? So let's go ahead and dive into that. So when it comes to log analysis, as you guys are already familiar with, we will be diving and using Wazoo. We will not only go through the Wazoo install, and I will be covering the 4.3 release, which is their latest release, and will be the architecture that they'll use going forward, and that being the Wazoo indexer, which we'll get into in some future videos. Not only using Wazoo to just collect logs, but also how to build our custom rules, right? So Wazoo gives us the ability to write our own custom rules. Us over at the SOC Fortress team, we have actually created a public repo that we've called just Advanced Wazoo Detection Rules, which incorporates some of our rule sets that we have applied in our cloud offering. If you're using Sysmon, it will enrich with the MITRE tags. It also does some more in-depth alerting, like, for example, if PowerShell was invoked with the execution bypass flag, for example. If you've customized any of your own rules that you think the public could benefit from, you can just go ahead and make a merge request into the repo, and we will review and push out if it works. So not only will we greatly appreciate that, but I know others would appreciate that as well. Now, when it comes to log ingestion, Graylog is our magic bullet. Graylog is not a tool that we have covered in the past. This will be new to you guys if you've been following along. Graylog allows us to not only ingest our logs, but also normalize our logs. It allows us to take advantage of some of the API enrichment that we'll get into. It also manages the indexes that are being written to OpenSearch, which is really nice. So we can configure our own index rotation within Graylog, and Graylog is going to manage all of that for us under the hood. It is super powerful, it's scalable, and it is fast, and it's really flexible in what it allows you to do. So, for example, we were discussing how it's really important to be able to normalize fields. So in the screenshot on the left here Graylog is ingesting a network connection from Sysmon. And I know that because Sysmon event 3s are responsible for network connections. So here what we're doing, and Sysmon writes its source IP addresses to the field name win underscore event data underscore source IP. So what we want to do is to be able to create a dashboard like what you see at the bottom here that will not only pertain to Sysmon network connections, but maybe firewall. Maybe we're ingesting logs from our firewall and want to show connections there as well. To be able to build a universal dashboard that shows both Sysmon and firewall types, right? We need to set our field. We need to set that to a universal field. And so that's what we're doing here. We are taking the win underscore event data underscore source IP field, and we are going to set that as source underscore IP field that will be stored in OpenSearch. And now as we're creating our dashboards, I now don't have to create a dashboard that details, event data underscore source IP. And then let's say our firewall one is like source, but it's all the way spelled out, SOURCE underscore IP, and build a dashboard for that. And then whatever other log sources that I'm collecting source IP events from, right? They now have a universal field mapping. Graylog will also cache logs as well. So if OpenSearch is down, Graylog is able to actually write logs to disk until Elasticsearch or OpenSearch. I'll be referencing them both probably interchangeably. So when I do, just know OpenSearch and Elasticsearch, I'm referring to the same thing. But if it is busy or backed up or down for whatever reason, Graylog can actually write those logs to disk until Elastic is in a healthy state. Now, our backend storage, to add even more confusion to Elastic OpenSearch, I will also be referring it to as the Wazoo indexer. So Wazoo has in their latest 4.3 release, they have forked a version of OpenSearch, which they're calling Wazoo Indexer. And so, as I also refer to Elastic and OpenSearch, you also may hear me refer to Wazoo Indexer. That will correspond to the OpenSearch or Elasticsearch. All three of those can be used interchangeably. I'll stick to a common one. I'm just going to stick to Elastic going forward. So because essentially that's what all three iterations of these are. They're just taking advantage of the Elastic 7.10.2, I think, is when Elastic changed their licensing. So that is the latest version of Elastic that Wazoo Indexer and OpenSearch are built upon. But that will serve as our backend storage. That will give us our fast searching and viewing of data. We'll be able to provide the access control to particular logs. So maybe someone from the networking team, we only want them to be able to view logs that are coming from the firewall versus someone on the security team could also view logs coming from endpoints as well. Grafana is going to serve as our visualization tool. I really prefer Grafana over Kibana. It also supports the ability to read from a lot more log storages, such as, outside of Elasticsearch. We could also read from MySQL. We could directly plug into like AWS CloudTrail or Azure. So there's a lot more you can do with Grafana that Kibana just doesn't support built in. And Grafana also gives you the ability to really customize like anything, which is really awesome. And I don't know what they do differently because they're both just making API calls to Elastic, but Grafana loads the data a hell of a lot faster than Kibana does. So maybe it's all the JavaScript that's within Kibana. I don't know, but Grafana is just a hell of a lot faster than Kibana is at loading the data. So I like to use Grafana as my visualization tool to use. Then when it comes to the intelligence enrichment, so for that, we are going to use OpenCTI and MISP, which are two awesome open source threat intel, kind of like databases you can think of. So we can enable multiple feeds within these guides, whether those be commercial feeds or free feeds that we can use and ingest, such as like Alien Vault, for example. And we're able to, and both of these tools support APIs, so we can automate the enrichment of our data on the fly as it comes in. So asking OpenCTI, hey, for this source IP address, do you have any feeds that this IP address has been found on saying that it is malicious or not, which we will cover in future videos. For case management, we are going to take advantage of the Hive and Cortex. The Hive will be responsible for actually storing our cases. So, what was the alert that came in? What are some of the observables associated with this alert? So being like host name, IP addresses, domain names. We can then, our SOC analysts will then use the Hive to assign tasks to one another to correspond on particular events. And then the Hive also can be integrated with Cortex, and Cortex is the tool that we use to run our responders and our analyzers. So for any actions that we want our SOC analysts to be able to run, such as quarantining a device, the Hive will make calls out to Cortex to actually do this job behind the scenes for us, which we will cover in later videos. We will then use Shuffle to kind of broadly surround all of these tools. So any automation that we want to do that we can't do with like a simple API request, or maybe we have to take advantage of multiple APIs to do a certain job, or maybe we need to loop through stuff. And rather than write our own custom Python or Bash or whatever scripting language you want to use to do a certain task, we can use Shuffle to do a lot of that. So some examples going forward, we're going to use Shuffle to automatically create cases within the Hive. We are going to use Shuffle to do some of our Wazoo automation tasks, such as like upgrading our agents or maybe using Wazoo to dump processes that are running. Shuffle will allow us to bring all of these tools together without the tools individually themselves being connected to one another, which is super awesome. So a lot of stuff to come on Shuffle in the future because it is a awesome open source SOAR platform that I love to integrate with the stack. We are then going to use Velociraptor as our investigation piece. So similar to the Wazoo agent, Velociraptor also has an agent that will sit on our endpoints. They currently support Linux, Mac, and Windows. And Velociraptor is an awesome tool. It comes bundled with a ton of pre-built jobs that we can take advantage of with just one click. So for example, in this guy here, we are listing the Chrome history on an endpoint. So I can run this job and the Velociraptor agent will gather all of the URLs that the end user visited within Chrome, right? And that's just one simple example. There is a ton of jobs that come pre-built with Velociraptor. You also have the ability to build your own and is a awesome investigation slash incident response tool to add to our set because it allows us to collect these forensics from remote locations, and it also allows us to quarantine a device while allowing us as well to still collect our forensic analysis, right? So say for example, I see Mimikatz is on a box, I quarantine it really quickly, but I still want to do some of my forensic gathering. So Velociraptor quarantines the device so it can't connect to anything else, but it's still able to connect to the Velociraptor manager. So I'm still able to collect this forensic analysis while the device is quarantined. And then when I'm done, I can release the quarantine if I've determined it's a false positive. And the host is now back on the network and is able to communicate as it was before. So really awesome tool that will allow us to really take our investigations to the next level. When it comes to health monitoring, I like to take advantage of InfluxDB and Uptime Kuma. So I like to think of health monitoring kind of in two phases. So you first want to monitor your endpoint. So for example, making sure Elastic is not overloading its CPU, making sure it is not running out of memory, making sure it still has appropriate disk space, right? So that's one side of the monitoring your server, your server's resources or important processes, right? So you also want to make sure your Elasticsearch service is always running. You want to make sure your Wazoo Manager service is always running because any downtime in those can have a negative impact on your SIEM stack, right? So that's one piece of it. The other piece is then also ensuring that your web pages are online and accessible, right? So for example, maybe I host Grafana on, grafana.sockfortress.co. I want to make sure that people from the outside world are able to traverse the internet and still render whatever web app I'm serving, right? So I see that the Grafana service is running. So from my standpoint, okay, Grafana looks great. It should be accessible, but maybe a firewall rule is implemented that blocks anyone from the outside world trying to connect to grafana.sockfortress.co, right? Maybe a new firewall rule was accidentally implemented that blocks that. So now my customers or my security analysts can't actually access that URL anymore, and that's a problem. So I like to use Uptime Kuma to monitor that piece. And what it'll just constantly do is just constantly make sure it gets a 200 response check back, or you can customize it as you see fit. So we have one portion that monitors the endpoint resources side of things, from CPU, memory, to also monitoring crucial services that you want to make sure are up and running. And then we also want to make sure our front end web apps are also accessible as well. Now let's go ahead and take a look at our diagram that kind of brings all this together. So hopefully I'm much more of a visual person myself. So I always appreciate when people put, even if it's a very high level, at least some sort of diagram together to kind of help me visualize kind of how these tools will be interacting with each other. So I know there's a lot more to it than just what this is, but hopefully this will at least allow you guys to kind of mentally picture a little bit better of how these tools will be integrated with one another, right? So our endpoints here, this could also be network devices or third-party services. whose logs I'm wanting to bring in, it doesn't matter, right? It all kind of starts at the endpoint. We then get the logs past our firewall, and these logs will first hit our Wazoo manager, right? So these logs will then first hit our Wazoo manager. Wazoo will ingest it, compare it against its rule sets, and all that jazz. And then we're actually going to be taking advantage of FluentBeat to forward the alerts.json file, which we'll get into more in future videos, to Graylog. So Graylog is actually going to sit in between our Wazoo indexer, right, and our Wazoo manager. Previously, in previous videos, and some of you guys may have deployments yourself of doing something like this, where your Wazoo manager writes straight to your Wazoo indexer. But in our instance, we're actually going to have Graylog intercept that so that we can do some of our log normalization, our API enrichment. We can take advantage of some of these features that may still be possible to do with the Wazoo manager, but may be more difficult. And so I like to use Graylog to do that. Plus, we get our index rotation management and all that stuff that is supported with Graylogs. And then after our logs go through our pipelines and our rules that we'll get to in future videos, they will then be written into OpenSearch. Graylog is we are also going to use Graylog to automate our intelligence enrichment. So as a log hits Graylog will also, depending if certain fields exist. So say, for example, we get a log from Wazoo that has the source IP field within it. And we want to use Graylog to run some threat intelligence on that source IP address. So Graylog will also be able to reach out to OpenCTI, MISP, VirusTotal, Gray Noise, whatever third-party intelligent, like anything that supports an API, we can do with Graylog as well, which is super awesome. So Graylog will also be responsible for doing our threat intelligence lookup before writing it to OpenSearch. And it does all this on the fly, which is beautiful. Then when it comes to our visualization, we are going to take advantage of Grafana, and Kibana does come bundled as the Wazoo dashboard. Kibana does come bundled with the Wazoo indexer install. Wazoo actually calls it Wazoo Dashboards, I think is the service that they call it, but essentially it's their forked version of OpenSearch Dashboards, which was a forked version of Kibana. So abstraction to the next level, I suppose. But we'll use this guy to interact with the Wazoo app, like web UI, right? That you guys are familiar with within Kibana. So it makes managing Wazoo a little easier. Of course, everything within the web app of Wazoo you could also do from the command line or do via API calls, but they make it a little easier by giving you that front end app that you can work with. So we will still use Kibana for that, but all of our visualizations and dashboards will be from Grafana. And that will be reading from our OpenSearch backend where all of our logs are stored. We then have our case management. So this will be the Hive in Cortex. He will interact with Velociraptor for doing some of when we want our SOC analysts to be able to, let's say, like list the Chrome history, for example, right? We'll use the Hive will call out to Cortex, which Cortex will then tell Velociraptor, hey, I want you to run this job, collect the events, and send them back to me so we can actually see them within the case. The Hive also stores all of its events and cases within a backend storage called Cassandra. They do also write like audit logs to OpenSearch as well, which we'll get into whenever we go through the deployment of the Hive, but its cases and all that related metadata are stored within a Cassandra backend. We will also then be able to enrich our observables with some of the intelligence enrichment using either OpenCTI or MISP or whatever other third parties we want to use. As I stated earlier, Shuffle kind of brings all of these guys together. So I have all of these tools kind of encompassed within our Shuffle block here. We'll be able to take advantage of any of these guys as APIs. Every single one of these tools supports or has an API built in, which is we can automate a lot of our redundant tasks. We can do a lot of we can do a lot more health checking. We can really get sophisticated by taking advantage of these tools APIs, and Shuffle is, in my opinion, the perfect tool to do that. And then we have Influx, which is our health monitoring, right? And this could also be like slash our Kuma uptime, but that doesn't really plug into any of our like server infrastructure. But Influx will also be monitoring the health of all of these tools as well. And then lastly, let's go ahead and get into our deployment strategy. So this will be, I'm gonna do my best to crank these videos out in order as you see them here. So we're going to first start with deploying our Wazoo indexer, which will be our backend storage, right? We first need a place to store our logs before we install like Graylog or a Wazoo manager and all that stuff, right? So I have this implementation rollout laid out like that accordingly. Some of these tools we can't really use until one of these other tools is deployed beforehand, right? So we're going to start with the Wazoo indexer. We will then do the Wazoo dashboards, which is just Kibana, but all of our visualization stuff will be Grafana, which will make sense later. We will then deploy Graylog. We will then deploy our Wazoo manager along with a few agents. We will then deploy Grafana and start to explore some dashboards. We'll then stand up our threat intel stack with MISP and OpenCTI. We will then install the Hive and Cortex. We will then get into Velociraptor and the Velociraptor agents install. We will then get to Shuffle to kind of bring all this stuff together. And then we will hit on our health monitoring. And that will involve InfluxDB, which is the backend storage, but Influx takes advantage of, you can take advantage of an agent called Telegraph. So this will actually be an agent that sits on all of our endpoints that monitors the system metrics, such as the CPU, memory, disk, etc. So again, this will be a series of videos that probably go well into 2023. And I'm going to do my best to release one video a day. A week. I'll do my best to stick to that. It'll just kind of be dependent on how my time looks for that week, but I do appreciate you guys' patience. I appreciate you guys following along, and I hope we can all learn together. And I look forward to working with each and every one of you. And I appreciate your time, and I will see you in the next one.